When we talk about the streaming technology itself now, how does it actually work? Give us an example in a car. Give me a ballpark number. How many polygons are we talking about, and why is it not possible to use these devices, but you have to actually calculate on the cloud, quote unquote, calculate, and then basically stream it back to the device?
This is where actually I would say at Hololight we've been the first coming up with a better solution for handling the data complexity of industry. As we were discussing before, depending on the product, the level of detail could be very high, and CAD usually CAD files, they are not they use a different technology to represent 3D data. These kind of devices, in order to display 3D data, they need everything to be rearranged in polygons. And when we talk about polygons, in this case, we are talking about a surface that has been redesigned in triangles. The number of triangles define, let's say, the computational power required. We can go from few hundreds polygons to represent a very small object to several hundred million when the project is very big and the level of detail and the number of parts is very high. Let's talk about maybe the Microsoft HoloLens, that for us is one of the, it's actually the most important device when it comes to AR till today. The computational power of the Microsoft HoloLens 2 will allow you to load a 3D object that can have around 1.2 million polygons. Looks like a big number. But when you look at for example, a full car, you can go easily from 90 million up. It depends how many parts you have inside, how much do you want every single surface to be perfectly rounded. So you can literally go to 100, 200 million polygons. So this is something that this device will never be able to display. And this is something that at Hololight we've been facing from the very beginning, because when we started to work with industry and they started to say, yeah, but I want to load this file, you know. Okay, that's impossible. So we came up with the idea of reusing actually some technology that has been on the market for other purpose for a long time, streaming. We know that if this design they get created with a workstation, they can be visualized. So now the point is we just need to send the same data to the device, but not to be processed, just to be displayed. So we have worked for our own software, and we have created a streaming technology that allows our application to run on a workstation, on a laptop, on a cloud machine, taking advantage of the computational power of very powerful hardware, and then we stream pixels to the device. So the computational power required by the device is very low, because we are actually taking advantage of the screen capability and the sensors. So we do manage only the exchange of data in terms of detecting the hands or detecting the environment. But the whole computation gets done on a computer and then gets streamed to the device. So we have started this journey several years ago. And today we have our solution running on premise. So on your computer, streamed to a device wireless, or in the cloud, streamed directly to your device, even with a mobile phone, being able to load several hundred million of polygons and be displayed with the level of detail you are expecting, but on a HoloLens. And this is today the only way you can match the expectation of the digital twin consumed as it is. So this is the streaming technology is a very important technology, I would say, for this kind of usage, because as I said, you don't do any compromise and you can consume your data the way you design them. There are different solutions on the market that provide also what is called hybrid rendering or remote rendering. It's a bit different from streaming, because, for example, solving the problem of the computational power, we have also introduced two solutions to different aspects. Security. As we discussed before, the digital twin is not something that you want to share with people around in an easy way. And if you look at how this device works out of the box, as I said, the computational power is on the device. So usually you install an application on the device, like you will do with your mobile phone.
Yep.
So this means that the application runs on the device, and the data, they need to be stored inside the device. And this is a massive security issue, because usually this kind of device, it's not that you buy one for every employee of the company. So this device, they get most likely shared between multiple people. And because you have to upload the data, and then you have to delete the data, you could always end up with someone that forget about it, or in a rush, they hand over the device to someone else.
Yeah.
The device stays around, and there are data inside. With streaming, actually, all the data, they stay where the computational power is. So on the computer, in the cloud, in any case, on a machine that is managed through IT policies. So there is security, there is user validation, there are a lot of aspects that will already solve the problem of the data management. And inside the device, there is no digital footprint of anything, not even the application itself, because the whole logic of the application runs somewhere else. And you just visualize the interaction with your data. When we go to remote rendering, that's different than streaming, because in remote rendering, you still have the logic of the application inside the device, and you just delegate the computational power for the visualization somewhere else. But it's something in between, so there is still digital footprint inside the device. And that's where actually we believe that streaming is the real answer for the industrial metaverse in this sense. And we have been hard working on creating also an infrastructure that will be able to support companies in hosting any XR application and take advantage of the streaming to device to be able to switch between multiple devices and keep security, safety, and software management inside a very manageable system.
Yep.